Halifax, Hampshire, and Amor. It's just me today. So yeah, packets to privacy. I am senior DevRel at NIM. We're a company that builds Mixnets and a decentralized VPN product at the moment. I'm going to give you a bit of a tour of kind of a bit of a flash drive through how packets move through networks, just so we're all on the same page, how inherently insecure they are, and how we can try and protect it. So initially, how packets move through a network. So we're all on the same page for the rest of this conversation. Data is sent between two network devices in packets. Packets are just chunks of data, right? So you don't have a stream to whatever server, whatever RPC endpoint you're actually trying to connect to. You send all the data in chunks, just so these things can multitask and talk to multiple things at once, right? Packets themselves, broadly speaking, contain a header, which has a bunch of information about the protocol, the type of content that's in this packet, the origin, IP address, and where the IP address that it's going to, right? Which correspond to physical space as well. Then you have the payload, which is your actual data. Sometimes you have tailors as well, which have more information. I'm not going to go through this whole list. You can take a picture or come and talk to me afterwards. But this is the metadata, the data about the data that is exposed by sending packets unprotected through a network between two devices. So where it's coming from, where it's going, the location, when, the type of packets, higher order patterns like the signature, what it kind of looks like, repeated communications, maybe also like device IDs, accounts, email addresses, cookies, fingerprints, all of this kind of fun stuff. And this is ultimately because when the internet was made, it wasn't made with network privacy kind of in mind. And the situation at the moment is that network traffic is captured and analyzed both by governments and corporations kind of en masse. They just blanket capture everything. And what they essentially try and do is, using machine learning, try and find patterns in this data. Who's talking to who and when, where you're located, what kind of traffic is being sent, and then relationships are inferred from that. Why are you only talking to you after midnight? What's the nature of your relationship? All of these kinds of things, right, so which can be used to de-anonymize you. There's a lot of different approaches that people take. So if we look at this diagram, right at the bottom, we have your kind of centralized VPN, shall we say. All you're doing is you're kicking the trust down the road. You're sending all of your packets to a VPN provider. Their server then forwards it on to wherever you want to go, right? You're not able to defend against anyone who can see the size and the timing of your packets and be able to infer what you're doing. Maybe you're downloading a video, maybe you're kind of getting your emails or something. And that is a centralized point of trust that you're trusting that that VPN provider will not sell your data and or when they are subpoenaed, give your information away. Tor does a bit better. It doesn't have a single point of failure in that regard, but against someone who can watch kind of the whole internet, which is kind of the situation we're in now, then they can still be de-anonymized. Tor does not add noise to their connection. It doesn't pad the packets so they're the same size. You can still do traffic timing attacks and all of this kind of stuff. Mixnets, however, fragment your packets into encrypted Sphinx packets, all the same size. They all look exactly the same. Individual packets are routed differently through a decentralized network of mixed nodes that delay the packets variably as well. So what you're doing is, and we also have cover traffic, so there's kind of hiding a signal in a noise idea, right? So what you're doing is you're reducing the capacity for an observer to be able to pull patterns out of looking at this network traffic, right? To be able to de-anonymize you. And another technology we're working on as well, ZK NIMs, which are anonymous credentials for payments, because non-anonymous payments are a problem. I want to pay for a privacy service that helps me out, even if I want to pay with Molvad, and I want to pay in Zcash or use Railgun or Monero. They're still susceptible to network de-anonymization, and generally will have a small anonymity set of people who are using that stuff to pay for a VPN. However, privacy loves company. You need to have as big an anonymity set as possible, the possible sets of variations of actors to basically make this pattern finding impossible. Therefore, you need to be able to construct a way where people can actually pay in fiat or pseudonymous cryptocurrencies, right? But the usage is cryptographically unlinkable to the actual payment. So I can basically say, yes, I've paid for this in, with my credit card. However, you can never tell when I'm actually using this credential to access this privacy service itself. There are also selective disclosure credentials, which means that you can prove certain things about yourself, maybe that you have paid for something, and in a generalized sense that you've gone through, you can pass KYC, you've done another payment, you can vote in a DAO. It's decentralized because it's generated by our validators, and it's a combination of the Coconut and offline eCash schemes. Finally, NIM VPN is the first kind of product app that's being built on the Mixnet for network traffic protection. So we are using ZK NIMs for private, unlinkable, re-randomizable payments and access credentials. It has two modes: the anonymous mode, where it goes into the Mixnet and you get the full metadata protections of the Mixnet. And it also has a two-hop dual tunnel-in-a-tunnel WireGuard, which is using the outside fringes of the Mixnet infrastructure. If you want to, we have an open beta right now. Also come and talk to me afterwards, and I have flyers with credential codes on them so you can try it out. I am also DevRel. If you want to build with this, because all of this that I've just said also applies to all crypto apps, wallets, everything, check out our Builder docs or come say hi afterwards. Thanks.
Thank you, Max. So do we have any question? Oh, over there.
Thank you. So if someone is using, there's the simple mode that's faster and the more complicated node.
Yep.
If someone is using the simple node, what can the government find out about me?
Okay, so you still, the speedy mode, where you have tunnel in a tunnel, right? You're disintermediating. None of the infrastructure that your traffic is going through, neither of the gateways that it's passing through, can have the full picture of either where your traffic is going or where it's coming from, right? So you're breaking those two things apart. NIM also has anonymous reply systems as well. So you can talk to a service and then you kind of send, let's say, pre-addressed envelopes along with that traffic. So the replies are all anonymized. So the people you're talking to don't know who you are, basically, right? So you never dox yourself. It doesn't have the addition of the noise and the mixing. So there is that to be said. One of the things that we want to aim for with this is split tunneling. So then you kind of get to a point where if you can capture, say, all of your devices' networking traffic, and then the stuff that is essentially asynchronous, messaging apps, email, anything that's not like browsing and streaming, basically, you can send through the Mixnet mode. And then for the other stuff, then it's still better than the vast majority of other options out there, basically. Yeah.
Yeah, I started using it yesterday. Thanks.
Sick.
Do we have any other question over there and there?
Thank you for the talk. Just a question. So if you want to have a decentralized VPN solution, I assume?
Yeah, that's what the speedy mode is, essentially, yes.
So the exit nodes, the traffic is basically internet traffic that comes out at the end.
Yeah.
So how do you protect those node operators from malicious traffic? So if there would be like illegal content being downloaded from the location where I'm at as a node operator?
We're relying on using Tor's tunnel list. So we're basically like, Tor and a bunch of other people have had this problem for a very long time. So we're kind of using a lot of the public resources they have there in terms of the block lists and everything that they maintain. So we're starting off with that, but we're also working a lot with our operators and kind of putting together, making sure that everyone's running in a particular legally okay way and that they have protection as well. But it's a thorny problem. It's a constant problem. But yeah.
Okay, well, thank you very much. Unfortunately, we won't have time for another question. Thank you very much for your presentation.